So this is the beginning of our look at quadratic functions and parabolas. So the parabola is the shape, and the name of the type of function or rule is a quadratic. Well, let's see, we've got this little equation we're given here. As you know, for table of values, you can substitute different values of x. Usually we pick fairly, straightforward, fairly small numbers. And sometimes it's good to look at either side of 0. So they've got -2, -1, 0, 1, and 2 there for x. X is what we put in. And we've got the rule here. This is y. So we've got -x squared plus 4. Okay. So, we've done this before, haven't we? We've subbed numbers into equations. And let's see what we would get. So let's have a close look at the rule. It says -x squared plus 4. Now remember our order of operations. -x squared. That part, that really means -1x squared. Now remember our order of operations, whether you learnt BOMDAS or some other acronym, we've got to do powers of before multiply. So you've got to multiply 1 there, we've got to do the powers of. So we've got to do the squared bit first, and then we multiply by -1 second. Okay, so if we put -2 into the equation, so we've got -2 squared. You can see that just there. -2 squared is -2 times itself. And then we times it by -1. Alright, so -2 times -2 is positive 4. And then we times it by -1 on the end, or on the front. That positive 4 becomes a -4. Now this rule's also got a plus 4 on the end, so now -4 plus 4, and you can see the answer is 0. So we'd put in 0. Okay. Let's see what it looks like once we keep repeating those steps for the other values in the table. And let's see what the shape looks like. And here we have it. So there are all the calculations. And there are all the x values there. These are all the y values. You can pause the video to have a closer look at the calculations. But we've got x values and y values, and then we fill out the table right to the end. So each of these are points. So for example, the first point here in the first column is -2, 0. And we've got another point there, another point there, another point there, and then the final point will be +2, 0. Let's plot these. So -2, 0, the first point is that point there. Then we've got -1, 3. You can see that there. We've got 0, 4. Then we've got 1, 3. And then we've got 2, 0. Now look at the shape. It does not make a straight line. So these are not linear functions. Not linear. Okay, so that means it's not in the form of y equals mx plus c. Okay, so it's not that. In fact, this is a quadratic, and you can tell it's going to be by the squared term. So if the leading term is a squared, it's going to be a quadratic. Quadratic function creates a parabola. So that shape is called a parabola. It's not a straight line, it's a curve. Okay, so parabolas can have that sort of shape, and that's called a negative parabola, and that sort of shape, which is a positive parabola. They're the two types we will study. So why are we studying them? Well, they exist in the man-made or human-made world. And for example, that's in St. Louis in America, that structure. This is an old bridge. Can you see the parabolas in each of those? So it's pretty easy to see the parabola in that one. That one, the arch of the bridge where the water goes through, that makes up a parabolic shape. When water is pushed through a jet, like in a drink fountain or a ornamental fountain like that, you can see the water jets make parabolas. Okay, you can see on the edge there that we have a parabola. Another application of parabolas is what's called a trajectory, which is pretty much, if we ignore the effect of wind resistance, it's pretty much the path of an object that's been projected. Now that might be a kick or a throw or a shot out of something like a gun, or many other things. Okay, it's called a trajectory, and that's a parabola as well. But not all parabolas are that shape. As I said, some are that shape. If you think about the profile of a satellite dish, okay, and it might be that shape there, and then of course it's that basic shape, and then it's rotated around to give a dish. So it's got lots of parabolic tracks in it. So a lot of reasons to study parabolas, and that's why every course studies them in high school maths. Okay, important things to note. So the graph of a quadratic relation or a quadratic function is called a parabola. So a quadratic equation will give a parabola. That's your basic shape, or that's your basic shape. There's two major shapes. The basic one, the most basic one, is called y equals x squared, but sometimes they can take this form here. Y equals ax squared plus bx plus c. So an example of that might be y equals 2x squared plus 5x minus 1. Okay, so that's an example of a quadratic, but this is your most basic one. The one we just saw before was y equals negative 1x squared plus 4. So they're all quadratics. A parabola is symmetrical. Okay, and there's an imaginary line called the Axis of Symmetry, which goes up and down, and it has one turning point which may be a maximum or a minimum, and that's your turning point there on that one. That's called a minimum turning point, and the maximum there, because it's the highest point, whereas on this one it's the lowest point, that one it's the highest point, but they're both called turning points. Also, in this example, we have a quadratic, and that's the graph of it there. Some key features are shown. Make sure you know that that is called the y-intercept, where it cuts the y-axis. That should be the same as for linear functions. The x-intercepts, now it has up to 2 x-intercepts. There's one there and one there. It depends on the quadratic. It can have, a parabola can have 0 or 1 or 2 turning points. So it depends on where it sits. If you could imagine that parabola sitting up higher so that it doesn't touch the x-axis at all, that one would have 0. So they could have 0, 1 or 2 turning points. The axis of symmetry is that imaginary line in the middle. It's dotted. You can see it there. And that's your axis of symmetry. It's x equals 2. X equal lines are vertical lines. So x equals some number. Remember from our previous work, is a vertical line, and you can see that axis of symmetry indeed is a vertical line. So why is it x equals 2? If you look at the halfway point between these two x-intercepts, 1 and 3, because it's symmetrical, it will go halfway between that. It's 2, so anywhere on that line is x equals 2. Let's look at an example. In this example, first thing I've got to do, given the graph, it's a parabola, so it's a quadratic. What's the equation of the axis of symmetry? Well, we can see that there's the middle, so anywhere along here is where it's symmetrical about, so that is the axis of symmetry. What's it go through? What x value? Negative 3. So the equation to the axis of symmetry is x equals negative 3. What type of turning point? Well, that's where it turns around there. That's your turning point. Turning point is a maximum. It's either a maximum or a minimum. So this one is a maximum turning point because it hits the top bit. What are the coordinates of that turning point? Well, we can see it there. It's the point negative 3 and 5. X-intercepts, it has 2. The x-intercepts are the point where it cuts the x-axis. That there are 2 points. 2 points are -5, 0 and -1, 0. You can see there in the green. The y-intercept, there's only ever one y-intercept, and we can see it down the bottom there. Just get some highlighting happening. You see that's where it cuts the y-axis, and that appears to be when the y-axis is -5. So that would be the point 0, -5. Time to try some activities.